online homework set. Not for the best. I mean, the people who sell it will find ways to prove that it's superior to other things, but that's just salesmanship, I think. Anyway, I digress. Let me begin with a word of prayer, if you don't mind. Heavenly Father, we thank you for this day. I thank you for the students. Just ask you to bless our work today, Lord, and just help. We just pray that you be glorified in what we do. In your name I pray, Lord Jesus. Amen. I should, by the way, have the solution posted for the test 2 by the end of business today, if I remember. Before I go home, I intend to post it. I have been delaying because I had a couple people that were kind of still stringing me along to take the test, but they're done now, and and generally speaking, this is why I don't allow makeups that much long after the test, because then I inevitably delay posting the solution, and I really do not like to do that. So anyway, so let's look at an example. But before I do that, are there any questions about the homework? Is there a particular one you'd like me to look at? I should tell you this: if you're interested in just seeing me work out homework problems, like on Wednesday in section 4, the one that comes after this, I think we worked like 10, 15 homework problems. I don't know, like a lot. I worked a lot of homework problems in there. So if you're, whatever we worked today, I'm sure there will be more. If you're interested, you can look at section 4's YouTube video from Wednesday. It's pretty good, I think. Let me just dive into it. I'll try not to repeat myself, but you know, this is part of the problem with teaching 4 sections of this class, is there comes a point where I forget what I've done in this section, and see if I had done what I should have done, right, is to watch the video from this class last time, and then I do better for you, right? But I didn't get a chance to. Sorry about that. So let's just look at number 26 is a kind of good warm-up problem. Let's do some of these. Like, what's log base 2 of 16? Can you tell me what's log base? Oh, that's annoying. Log base a half of 8. I try not to talk about that, but since it's in the homework, I'll talk about it for a second here. Log base e of 1 over e squared. Log base 10 of 0.1. Let's just start by working these out, okay? What do you guys, what should we do here? What do you think? Use a calculator? No, there's no need. And the point of this is to not use a calculator, actually. So this is log base 2. What is 16? 16 is 2 to the 4th power, right? Because 16 is 2 times 2 times 2 times 2. So what is log base 2 of 2 to the 4th? It is equal to, by definition, 4. Okay. So remember, basic fact here, log base a of a to the x is equal to x again, right? So let's remember that. So here, this is very, very awkward. All right, fine. Here's this. There's just no nice way to talk about this one. I have to rewrite 8 as a fraction, and to do that, that's 1 over 1/8, okay? It's kind of a weird step, but there it is. 8 is 1 over 1/8, right? Which is equal to, and so if you see a different way to do what I'm doing right now, more power to you, but that's 1/2 cubed, right? And that, you see, is log base 1/2 to the 1/2 to the what? To the minus 3 power. So the answer is minus 3, right? Yeah. Now I did make a I have made statements in other sections. I don't know if I made a statement in here yet, but I told them I'd never test on log base fraction. Like there might be a couple ones in your homework, but that will not appear on the test. On the test, I will test on like log base 2, log base 3, log base e, log base 10, those things. I think that's more appropriate. Okay, so log base e. So first of all, log base e, we have another notation. We could write this as natural log of e to the minus 2, yeah? I'm just saying, like, notation-wise, this is the natural log. That's e to the minus 2, and so the answer is minus 2. All right? And what is 0.1? It's 1/10. So there's different ways you could look at this. And by the way, this is the common log, so I can drop the 10. Yeah? So you could look at it this way. This is log of 1 minus log of 10, using the properties of log, right? What was the other one of the properties of log? Remember, we have like log of AB equals log A plus log B. We've got log of A over B is log A minus log B. And we've got log of A to the power P is P log A. These are your log rules, if you will, log laws. Log laws. Like blah, blah, blah. Sorry. Log of 1 is 0. Log of 10 is what? Log of 10 is just 1. So the answer here is minus 1. What's the other way I could have done this problem? This is really just log base 10 of what? 10 to the minus 1 power, right? Like, why don't you just do that? I don't know. I'm just trying to show you guys things. There's no reason I did it that way versus this way. It's just to try to smell the mathematical roses, so to speak. No one says that. What's wrong with me? So do you guys have any particular homework questions you're interested in me working? If not, that's fine. I'll just pick some and sample and work them out. So let's get to it. One I almost got stuck on. Let's see here. Let me find that one. If I could find it. Where'd that thing go? I'll try to work some of these ones in the 30s for you today. There's lots of simplification, simplify the log problems. I kind of want to start with solving equation problems to start with. There's a particular one in here I wanted to look at because it almost stumped me last one of the other sections here. So a lot of these problems are about identifying a graph, right? Man, where'd that problem go? Sorry, guys. It's probably hiding in plain sight. Ah, here it is. Number 29. So this was number 26, or like this is essentially like number 26 from your homework. All right. Example 2. This will be like number 29 from the homework. And it's really weird in terms of the logical structure here. It's different than really any other problem, I think. I think this is a one-off. I don't think there's another problem like this in the homework set, so don't miss this one. In terms of like, make sure you understand this one, because if you don't understand this one, then you don't understand this kind of problem. There's no other homework problem, as far as I know, that quite tests you on this idea. Okay? How do you solve this?
U cubed is 64 over 343 because 3 is the exponent.
You cube? What do you say? You said you cube the... I think that's... I think what you said is right. So like, here's the thing. I wrote this, right? Log log base a of a to the x equals to x, right? But we also have a to the log base a of whatever is equal to whatever, right? So the point is, if we take both sides to the a power, that's I mean, if I have, if I want to get rid of a logarithm, base x, right? What I want to do is like think about taking both sides to the x power is the way to think, way I thought about this one. So like I can think about x to the log base x of 64 over 343 equals x to the third. I mean, I guess another way to say this is just this. The exponential form of this equation is what? The exponential form of this equation is what I'm about to write in red, which is simply 64 over 343 equal to x cubed, yeah? And maybe that's the better way to say this, is that if we take this logarithmic equation, right? This is the corresponding exponential equation, right? So you have a smattering of homework problems that ask you to convert from logarithmic to exponential form or vice versa. This would be an example. I'm converting this logarithmic equation to the corresponding exponential form. To say that log base x of 64 over 343 is equal to 3 means that my base, which here is x, if I cube it, I get 64 over 343. Then how do I solve this? Take the cube root of both sides, right? So then we get x equal to the cube root of 64 over 343, which is, by the way, the same as the cube root of 64 divided by the cube root of 343. And, well, the cube root of 64 is 4. And 343, I think, is 7 cubed. So this is 4/7. The answer here is 4/7. So I don't know why. I personally have a mental block about this equation. This is sometimes, like, there are days I get stuck on this one. I don't know why, but I do. Number 30. Let's look at number 30, yeah? Example 2, example 3. Oh man, what a loser of a marker. Here you're looking at log base 49 of the 9th root. The 9th root of 7 equals to x. You're supposed to solve the given logarithmic equation. So this is kind of a dumb equation. I mean, isolate x, right? Can you guys isolate x? Oh man, it was this close. I think x is already just isolated. So really the question is, how do you calculate log base 49 of the 9th root of 7, right? You're like, well, I use a calculator. Fine. If you have a calculator that can do that, more power to you, but I do want an exact answer here. So if you've got a calculator that calculates log base 49, can you give me an exact answer here? What is it? Because if you can't do that, then you need to figure out another way, right? So what this is log base 49 of 7 to the 1/9 power, right? So by the power property, I can pull out the 9th, right? And I think a good identity, I may have told you guys this already, but I think something we should have on our formula sheet is the following. Like log of a squared of a is equal to 1/2, yeah? Or another way to say this is, if I have the log base a of the square root of a, I get 1/2, yeah? Maybe I shouldn't use the same letter. Maybe put a b here just to be different. My point to you is this is what? 7 is the 1/2 power of 49, right? I can rewrite this as, 1/9 log base 49 of 49 to the 1/2 power, yeah? Which is just going to give me 1/9 times 1/2, yeah? So the answer is 1/18. So let me take a break from the equation solving here and work a problem that involves graphing. Yeah? Let's do a graphing problem. I hope you got the top hat. I'm about to erase it. Who's got it? So let's see here. So example 4, suppose you want to graph y equals to 3 minus the log base 2 of x minus 3. Can we do that? What are the steps to graphing that log? We can think about that as a transformation of graphs problem, right? And how would that go? What's going on here? I'm thinking I start with y equals to log base 2 of x, right? And then think about that goes to y equals to log base 2 of x minus 3. What's that? What does that amount to? I shift what? I shift right, I shift left. What do you guys think? Shift right 3, right? And then what do I do? Oh, negative, right? So then y equals minus log base 2 of x minus 3. What's that do? What do we do? If we change to minus, we flip over the x-axis, right? Reflect over x-axis. Reflect over the x-axis. And then finally, what? My last finishing move here. Add 3, right? 3 minus the log base 2 of x minus 3. Then we shift up 3, right? So what's the basic graph we're working with here is what? The log graph. What's the log graph look like? This is something you should know, yeah? So the log graph, if we can track, let's say, 3 features on the graph, we'll do pretty well here, right? What are 3 interesting points on the graph of the logarithm? How about this? I start out with, I've got a vertical asymptote where? The vertical asymptote for the log is the y-axis, yeah? So I've got this vertical asymptote like that for the log. It looks something like this, right? This point is 1, 0, right? Because log base anything, but certainly log base 2 of 1 is equal to 0, right? And I also happen to know that log base 2 of 2 is equal to 1, right? So over here, if I go to this point right here, this point would be 2, 1. So here's 3 interesting features to the log graph. I've got a vertical asymptote, I've got an x-intercept, and I've got another point, right? If I track what happens to these 3 points, excuse me, these 2 points in this feature, I should have a pretty decent graph of the resulting transformed thing, right? So shift, so I'm gonna, if you don't mind, I'm gonna clutter this graph up, okay? So basically here, I shift right 3, right? So basically like this, yeah? So this point becomes what? 4, 0, right? This point up here shifts to what? Add 3, right? So 5, 1, yep. So here we're looking, this graph right here would be y equals log base 2 of x minus 3. Then what? I have to flip it. I'm going to draw a new graph for that one, if you don't mind. So when I flip it, I'm going to have the point 4, 0, but the point 5, 1 flips down to 5 minus 1, right? I probably should have drawn the shape first. Roughly, there we go. So, sorry, I'm trying, guys. So this would be, good grief, 4, 0. And this point down here would be 5 minus 1, something like this, yeah? And then what happens? So the vertical asymptote's still here, you know? I reflected over the, now I still have to shift up 3, right? So final answer should look something like, I'll do it over here. So I'm supposed to shift up 3, right? So this point, instead of being 4, 0, it should be at 4, 3. And instead of being at 5 minus 1, I should have like the point 5, 2. And the log in question looks something like that. So, sorry, I'm never happy with my log graphs, honestly, guys, but I'm trying. So there's about the best I can do for you here at the moment. And this we're looking at is the y equals to 3 minus log base 2 of x minus 3. So we can, a lot of the problems in your homework, you can understand the graph by just doing transformations of graphs, right? You just think about starting with your basic log graph and like transforming it. Most of the graph problems you can do like that. Yeah? Yep.
So even if the graph shifts, the vertical asymptote stays on the y-axis?
That's a good question. Did I do that wrong? What do you think? I wouldn't put it past me. Yeah, if we shift right 3, what should happen? Oh man, look at that. That's, oh, goodness gracious, what's wrong with me? Yes, the vertical asymptote, you guys should have called me back here, you know? Our vertical asymptote, even here, the vertical asymptote should be where? X equals to 3, right? That should still be true of this one. So like my graph isn't quite right. Let me fix it. So the vertical asymptote should be like here, x equals to 3, and I knew something was wrong. It should be bent more like this. If I do this right, the shape of the logarithm should be the same as like the shape of the exponential function, just turned on its side, right? What's the exponential function's graph look like? It looks like this, right? So your logarithm should also look like that, but it should be turned sideways and either upside down or right side up, depending whether there's a minus or not. But so there's definitely not this like hockey stick thing here. That's just an artifact of me not being a good grapher up here at the moment, yeah? And yes, if we do a right or a left shift, the vertical asymptote for the logarithm definitely moves. Thank you. So like here also, so it should have been more like that. Thank you, thank you. All right, let's see here. Let's do some log simplification problems here. All right. So here you're asked, this is number 37, example 5. You're given log base 3 of 7y over z, and you're basically asked to simplify that, all right? So that's one of the questions. Another one, number 40, you're given 2 times log base b of z plus 1 plus log base b of 3z plus 6. All right? And again, you're asked to simplify it. And this one's multiple choice, so they give you 4 choices to pick from. And since I give you like 5 tries on the homework, if you don't get this one right, it's on you. Right? Yeah? Like my other class, I think I gave them like 15 tries in the WebAssign, and there's like a yes or no question at the end of their homework, and a student came to my office hours, asked me about it, and I'm just like, but you know it is a yes/no question. 15 tries. I mean, I will try to help you understand it. I'm happy that they're trying to understand it. That's good. But, you know. Okay, so both of these problems, they're about applying the properties of logarithm to simplify the expression, right? It's just in 2 different directions. The first one is to expand. The second one is to collapse. So we can either expand or collapse an expression using logarithms, using the laws of logarithms, okay? So let's do it. So the first one, what we're going to do is simply this. This is equal to, I'm going to write it down here if you guys don't mind, because I think I didn't leave myself quite enough room. This is log base 3 of 7 plus log base 3 of y. And because z is in the denominator, we subtract minus log base 3 of z. And that's it, folks. That is it. That is the end of it. Right there. That's all you can do. If you read the instructions to number 37, you'll see that that actually adheres to the instructions, yeah? All right. Now, how would we kind of undo that? How can we put this together? How can we put this together in a single logarithm? What do we do here? So I'll do it in 2 stages, right? First of all, we can bring the 2 inside. If we bring 2 inside the logarithm, what happens? We get z plus 1, 2 comes up to here. See, it becomes a square. This is one of the properties of logarithm. A power inside becomes a multiplication outside. This is a property of the logarithm. And this one, right? I'll just leave it. It is what it is, right? I could factor a 3 out here. I mean, inside here, I could factor it out, yeah? And so if I put these together, I get log base b of z plus 1 quantity squared times 3z plus 6, right? Now, this is a multiple choice question, so you're supposed to like simplify it until you find one of the choices. That's the game. So I did a simplification, right? And I look over here, and oh, it's one of the choices. So we're done. Okay. So that's actually one of the answers. So I mean, that's all there is to it, really. Let me do some more examples, which are not directly from your homework. Yeah. Yep.
Example 6 is what number?
Oh, number 40. All right. There are some ones in the homework that are a little bit sneakier. The ones that they're most difficult are when you're given. So let me work one that's harder than your homework. All right. Let me make up a problem that is significantly well, it's not significantly harder than the homework, but it's the same idea as one of your homeworks, but it's like more ugly because it's going to require calculator work. Okay. So what I'm showing you right now is an uglified, let's say, an uglified version of number 18. So example 7, like number 18 made ugly. Ugly. All right, so here's the deal. You're given that you have an exponential function, all right? You're given that you have an exponential function whose graph looks like this. And so I'm going to tell you in particular that this is at -2. It passes through the origin. And I'm also going to tell you that this point over here at, let's say, you know, is like at 2 comma 5, whatever. And my question is, here's the question. Find A and C and B, okay, such that y equals to C, excuse me, rather B plus A x minus C. Let's call that f of x, right? It gives the above graph. Now, the number 18 is much easier than this because number 18 tells you that the graph that you're given in the problem has base 2 or base 3. And they tell you furthermore that the graph is either base 2 or base 3 exponential, either reflected, it's and possibly reflected across the axis or something. So basically, like, you have a lot more information in problem 18 than I have here. So the problem 18 tells you that the base is 2 or 3. All right, and you can look at the points and you can think about how 2 to the x and 3 to the x behave. And from that, you can figure out which choice it is, right? How would you decide whether given two graphs, which one is 2 to the x and which one is 3 to the x? Shifted around. Like, so here's a hint about number 18 before I come back to my much uglier problem, yeah? So a hint for number 18. Think about this. If I had, you know, something like this, and this is the 2 to the x graph, right? I go from 1 to what? To 2, right? Over here to 4, right? So this is, you know, 2 to the 1 equals to 2, 2 to the 2 equals to 4, and so forth, right? In contrast, if I look at the 3 to the x graph, I go from what? 1 to 3, right? Up to 9. See, because, you know, 3 squared is 9. 3 to the 1 is 3, right? So if you look at the graph that you're given, right? And if in that graph you go 1 over, but you go up 6, think about this. If you go 1 over, but up 6, right? That happens for the 3 to the x graph, right? But it doesn't happen for the 2 to the x graph. The y equals 2 to the x up here, what happens for that? You go 1 over, you can go 2 up, right? You can go 1 over, you can go 4 up, right? But if you look at it, if you shift 1 over, it's always a multiple of 2 that you're going up, right? If you go one step over, like if you look at it, if you keep going, up here 2 cubed is equal to 8, right? So my point to you is if you look at like 2 to the n plus 1 minus 2 to the n, that's 2 to the n times 2 minus 2 to the n, which is 2 to the, curses, that was 2 times 2 to the n. And so we've got, you know, 2 minus 1 times 2 to the n, that is 2 to the n. So my point to you is, by this little algebra, you're always going up a multiple of 2 for each step over in the 2 to the function. If we have the 2 to the x, it always goes in steps of 2, right? 2 to the 0 from going from here to here. It goes up by 2 here. It goes up by 4 here. The next one would go up by 8. The 3 to the x function, it goes up by 1, then by, excuse me, it goes from, oh man. Just a second. I think I said something wrong. 3 squared minus 3 is 3 times 3 minus 1, right? So that's 3 times 2. I guess it's a multiple of 3, right? What's 3 to the... I'm saying it the wrong way. Sorry, guys. I'll get it out of my system here in just a second. Well, anyway, the point here is that it should always be a multiple of... I did this math wrong. It was supposed to be... I'm sorry, I've got a mental block here. 2 to the n times... Is that right? Oh, I'm sorry. There's a difference between 2 and 3. I'm a dummy. Look, so like 2 minus 1 happens to be 1, but 3 minus 1 doesn't happen to be 1. It happens to be 2. So you get multiples of 3 here. Like, so the 3 to the x graph, it goes up by 2 for the first, going from 0 to 1, it goes up by 2. But going from 1 to 2, it goes up by 6. If you went from 2 to 3, you'd go up by, 27 minus 9, which would be 18, which is 2 times 9. It's always 2 times the power of 3. All right, enough about this. My point to you is that there's a very particular shape to the 2 to the x graph versus 3 to the x graph. And if you look at the data that you're given in number 18, you can identify it's either 2 to the x or 3 to the x by looking at these patterns. All right? But it is a little bit tricky, which is why I'm belaboring it here for a minute. All right, let's get back to my problem. How do we solve my problem? How do you solve this? See, I just made this up, so it's not going to have a nice base. I don't think. All right? I think we're going to have to use, like, algebra to figure it out. Now, this much I can say. Can you tell me what b has to be here? That we can read from the graph. B is the horizontal asymptote, right? So I can tell you that b is going to be minus 2, right? So definitely want to use b equals to minus 2 for this one. So we're looking at something like y equals to minus 2 plus a to the x minus c, right? That's my f of x. Now how do I figure out what the a and the c should be? Well, I've got 2 pieces of information here, don't I? See this? I got 0, zeros on the graph. So what's that tell me? That tells me that f of 0, right, which by the way is minus 2 plus a to the minus c, right? That's equal to 0 again. So that's one thing I know. See, I know that a to the minus c power is equal to 2. All right, that's one thing I know. But what else do I know? I know that 2, 5 is on the graph, right? So also, we know that f of 2 is equal to 5. What does that tell me? Well, that tells me minus 2 plus a to the 2 minus c is equal to 5. So this tells me that a to the 2 minus c is equal to 7. Well, I mean, this is something we haven't dealt with in here yet, have we? This is the first time this has happened to us this semester. But this is something we'll come back to at the end of the semester in more cases. But see, what we have here is we have 2 equations and 2 unknowns. How do you solve 2 equations and 2 unknowns? So a useful strategy is to substitute one into the other. How would we substitute one of these into the other? We could use laws of exponents, right? So this gives me a squared times a to the minus c equals to 7. But what is a to the minus c equal to? From the first equation, it's 2. So this is 2 a squared equals to 7. And from this I get a squared is equal to 7 halves. And hey, that we can solve, right? So a is equal to plus or minus the square root of 7 halves. So yeah, the base here it's kind of ugly. Now, is it plus or minus? Actually, we can make a choice here, right? We definitely want positive base. So we're going to put a equals to the square root of 7 over 2. And what do I make c equal to then? Well, now I can go back to the first equation. I can figure out what c is, right? Because now I have the square root of 7 over 2 raised to the what? Raised to the minus c power is equal to 2. How do you solve for c there? So that's actually like a lot of your homework problems. This problem we've just come to at the end of this ugly problem, this is a typical homework problem for you guys this week. How do you solve that? Now, usually your homework problem has x instead of c, but it's the same thing. What I would do when faced with that, I'd take the natural log of both sides. That's what I would do. I mean, you could do other things, but I think natural log is a good choice here. If we take the natural log of both sides of this equation, what happens? So we've got natural log of the square root of 7 over 2 to the minus c power, right? Equals to the natural log of 2. Now, by properties of the log, I get minus c times the natural log of the square root of 7 over 2 equals natural log of 2. Lo and behold, c is natural log of 2 divided by minus the natural log of the square root of 7 over 2. All right? And there you have it. That's the choice of c, that's the choice of a, that's the choice of b, which will produce this graph. Your homework involves all of these ideas, but not all at once and not as ugly as I've just made it, okay? Like, this is harder than your homework, what I just did, for sure. This feels like a bonus kind of question on the next test is what this feels like to me. All right, enough about that. Do you guys have a particular homework problem you'd like me to work? Nobody? All right. Well, in that case, I will pick one. Oh, my background, it makes me it's hard for me to tell the difference between a 3 and an 8. You know, an 8 is a lot different than a 3. Am I right? So here's one we can solve right quick, and I think you'll appreciate it. Number 21. Here we've got e to the 4x minus 1 equals e to the 2 raised to the x power. How would you solve that? So, sure, but before we even do that, though, we need to make sure we have e to the both sides. So this is e to the 2x, right? But you're right, we could take the natural log of both sides. I like it. And what's that give us? And of course, we could have gone directly to that as well because of the one-to-one property of the exponential, right? So the one-to-one property of the exponential, in some sense, is derived by taking the natural log of both sides. And then we solve for x, yeah? So we get 2x equals to 1, so x is equal to 1/2. And that's it. So they don't have to be hard, right? But anyway, there's a lot of graphing in this week's homework. I hope that you can